Hello. So I just want to make a correction. We were last on part 5, and so this is actually going to be part 6. So make sure that that correction is understandable. I'm sorry about that. So in this part 6, we're going to look at that y equals mx plus b. So we're going to look at this guy right here, y equals mx plus b, a little bit more in depth. And remember from the last segment, this is where you start, this is your slope, this is your rate of change, okay? And so we want to make sure that we understand what this is used for. Well, we're going to look at linear equations. Linear equations are pretty much straight lines. You know, they're straight lines, up or down, or even horizontal, even vertical. We're going to be looking at vertical, up, down, and horizontal, level. So this is where linear equations come from. And this is what we're going to be using. So I would like us to kind of take this and develop it more. So I want to give you this equation as well. So ax plus by equals c. This is a linear equation, but this is what we call the standard form. This is what we call a standard form. And this is the form that we're going to get into, that we're going to take it from this form to this form. So that's kind of what we're doing. So I want you to see that this here is really that. I'm hoping that you're seeing that. So, for example, this y is actually right there. This x is actually right there. And you can kind of see a lot of the similarities. So what I would like us to venture off into and do is take this standard form, and we can solve it and put it into this form if we really wanted to. And how we would do that is do this. Well, we want to have y by itself. So you would go your line, you would go properly, you know, ax minus ax here, and that would give you the by, and then this would give you the negative ax plus c. And then you can go b and get y equals that form there. Okay? So we can solve for y. But what if we wanted to work with this and find some information about the line? So what we're going to do is that we're going to use this standard form, but remember, keep this in your head because you need to remember that. But that's how we would solve for y in this equation. If that made sense, it's okay if it didn't. So we're going to use this guy right here, the standard form, and we're going to use something of it. So what I would like us to kind of look at in this, hopefully this short video on this, is kind of look at different aspects of it. So, for example, what if I made maybe a table of values? Remember what a table of values were? And looked at this. So let's do this. make a t-table. And remember, goes here, goes x and y. So I want us to put some numbers in. So let's put 0, 1, and 2. Okay. Now, let's do this. We have our equation here. So let's give you something to work with. So we have our values. Maybe we have something like this. Y equals 3x plus 2. Maybe this is the equation we come up with. Okay, when we have our standard form. But don't worry about that if you don't worry about it. So you can worry about this, or I tell you what, for now, forget about it for now. We come back to it. So look at this. We have this. Do you remember what we do here? What do we do here? What's our rate of change? So what's our slope? And what's our y-intercept? So what you're going to do, from this guy here, our slope is 3. If you want to, 3 over 1. Remember, it's a fraction. Rise, remember this is rise over run. Rise over run. So what's our y-intercept, our b? Remember what our b is? It's 2. Okay? So, if you plug 0 in to our equation, if you plug 0 in for right there, what do you get as our output? As 0 at 0. You get just 2, right? Okay. Well, what if you put 1 in? Remember, this is 3 parentheses 2. Put 1 in. What's 3 times 1? 3 plus 2 is 5. Okay. Now, what if we take that out and now replace 2 with x? We have 6 plus 2, which is, let's see, 6 plus 2 is 8, right? And you can keep going on and on and on with every value you plug in. But what I would like you to understand is that this is our output. Remember, this is our output. This is our output. And this is your input. So input, your output. And remember that this equation can also have this in it. F of x. Remember, the x is what you put it in. The x is what you call the input. The x is what you call the input. But what you get out is the output. So, just to make this making sure you know what you're doing, I want you to sing about this. If I were to graph this, so take a piece of graph paper or something else, and I have my x's and my y's. What is my values of x's? What do they go up to? They start where? From our data. They start from 0, correct? So they start from 0. And where do they go? What's my biggest x value? 2, correct? So it's going to go 0, 1, 2. So 1, 2. Okay? What's my biggest y value? 8. So it's going to go all the way to positive 8. So it's going to go somewhere up there. So it's going to go 1, 2, 3, 4, 5, 6, 7, and 8. So 2, 1, 2, 3, 4, 5. Okay? Make sure you number your graph. Does it have to be spaced out correctly? Yes, it should be. You can kind of exaggerate a little bit. You can kind of make this wider, but really you should actually make your graph a little bit more presentable and not jump up so much because you're trying to get a picture. So what happens at 0, 2? So 0, 2. 0 up 2. Okay? 1, 5. 1 and 5. 2, 8. 2, 8. What's starting to happen? Well, you have what we call a linear equation or a line, a straight line. So it goes like this. Make it bigger. Exaggerate. A piece of graph paper would be a lot better. But remember, a line just doesn't go, it doesn't stop. Well, it stopped because I made it stop. But really, a line goes on and on forever. It goes on forever. So this line should actually go on like that because it's a line. Well, tell me something about this. Well, let's talk about this with our equation here and our standard equation we had. But let's just focus on this equation for now. So let me ask you something. Where does this line, so I'm going to ask you a couple questions. Where does this line hit the y-axis? Where does this line hit the y-axis? Where does it hit the y-axis? And if you say at 2, you are correct. So it hits the y-axis, so it hits the y-axis at 0, 2. Remember, it hits at 0, 2. So that's what we call the y-intercept. So this is what we call the y-intercept because it hit here. That's what we call the y-intercept. And I want you to understand one thing. Look right here. There it is. There it is right there. When x is 0, y is 2. That's what we call your y-intercept. I want us to kind of look at some more of these real quick, just today, for this part, because we're trying to understand what these y-intercepts are. So let's do a couple notes here. So, note. So I want you to note this. When x is 0, y, when x is 0, you get your y-intercept. Okay? When x is 0, you have the y-intercept. When y is 0, well, there's no y's of 0 on this yet. There could be, if you keep putting some numbers in, and that's what we're eventually doing, you would get what we call the x-intercept. So, I want you to note this. Because this is pretty much what we're going to be getting into with our graphing, with using the y-intercept that we got. So when x is 0, you have the y-intercept. When y is 0, you get the x-intercept. Make sure I got that correct. When x is 0, you get the y-intercept. When y is 0, y is not on here yet, but we will get to it. You get the x-intercept. So we want to understand the x and y intercepts and what's the relation to them. So I'm trying to have you understand in this part, if you are given an equation, can you understand what the graph and the y-intercepts are? Can you understand the graph and the intercepts? So that's what we're going to be doing. So on the next part, we will dive into more of these, and we will also look at that standard equation again and kind of see what it is. But I want you to one step at a time. Okay? So I'll see you in the next video.